Hello, hello, hello. Hello, hello, hello. Okay, cool. So I think we're starting right away, right? So first of all, welcome. How are you doing? Happy semester's over. Barely any exams left. Nothing to do like for the next couple of weeks, right? Like great. Now I know you guys have exams. It's all good. So maybe let's start right away with the organizational things and like one of the first questions that we get usually every year. So first of all, welcome to Explainable AI, right? So my name is Robert Vudikov. I'm basically head of the Intuitive Robots Lab, but more on this in a second. So one of the first questions we usually have or usually get from you guys at the very beginning is, oh, I have exams this week, or I cannot make it because of X or Y or whatever, right? So no worries. Like we know this, it's completely fine, right? Like I don't think you'll like have any issues. You will see that the lecture is very interactive, so you will make friends here very quickly, right? So and like hopefully not all of you are at the exam at the same time, right? Or like at the other exams at the same time, so you will be able to catch up. We will upload the recordings towards the end or towards towards the end of the lecture itself, right? So the reason why we do it this way is because we want you to be here. And as soon as we start uploading the recordings right after, right, the lecture, people tend to just disappear, right? Because they prefer to learn by themselves on the lectures. We don't really want that, right? So we want you to be here, but we will give you the recordings afterwards for self-study, right? So prepare for the exercise, prepare for the exam. Yeah, so with this, no worries about that. So let's keep going with some organizational things. As I already mentioned, my name is Ruth Vulikov, and I'm leading the Intuitive Robots Lab. And in this lab, basically our mantra or like our goal is that we kind of want to reach a more intuitive human-robot interaction with non-experts, meaning people that don't have everyday interactions with robots, or that are not like experts in like machine learning or robot learning, and for not even in the tasks that are trying to teach or interact with the robots, right? So when we're trying to do this by leveraging basically these auxiliary information, so something like gaze, but also nonverbal acoustics, gestures, right? All this information that we humans are privy to, but robots these days don't actually use, right? So all of this multimodalities there should be integrated into different like areas like interpretable representations, but also goal and data-driven explainability, right? And also interactive learning. And in order to do so, we need to leverage methods or like paradigms like human-robot interaction, imitation learning, scene and task learning, and so on, like model learning, reinforcement learning, and scale behavioral learning. So we started the group as an Immunuta group in 21, right? So like, and since then we've grown quite a bit. We currently have 8 amazing people that do all of the work and me talking about it, right? So this is like our group right now. Yeah, but it turned out that in the last couple of years, we pivoted a little bit, so we're still leveraging all of these multimodalities, but we actually have a different goal right now. So it's like the high vision is still to make everything more interactive, but the path that we're walking right now is more towards foundational behavior models, right? And it turns out that, so what that is, we can actually talk about, or we will talk about towards the end of the lecture, where we're talking about our actual current research, right? So, but like just to give you some idea already. And so the reason why we decided to pivot now is that we figured that all of our work of the last couple of years, right, actually went along this line of generative AI, and in particular how to transfer this to learning robot behavior, right? So we actually developed our own diffusion policies, starting from diffusion and flow matching approaches from the computer vision community, and we leveraged the like insights from the language modeling community, like in LLMs or VLMs, to develop new vision language action models. And we also combine these into VLA flow models. And in order to represent behavior, we also introduce something called action tokenizers. But all of this we will also see towards the end. It's just, I thought that's more appropriate to show you what we actually have done in the last 1.5 years, rather than what we started back in 21. So like, yeah, if any of this sounds interesting to you, just like pay attention to our lecture. And towards the end, we will talk about details in this regard. Okay, but back to the actual content of this, well, the next week, right? So we'll talk about interpretable methods, linear models, for instance, and prototypes. right? So today about linear models, and sometime later this week about prototypes. We will also talk about how to deal with this more high-dimensional input spaces and more complex models, right? So through, for instance, what we call saliency maps, so visualization of these high-dimensional spaces, but also visualization of the low-dimensional spaces through dimensional reduction disentanglement. We'll talk about model agnostic methods, actually Lyman Shep today and counterfactuals tomorrow, right? So model agnostic meaning how can we introduce interpretation into like a system without actually depending on the model itself, right? And then we talk about something that we call advanced models, right? Where we talk about, for instance, transformers and in particular attention maps, but also things like goal-driven explainability in LLMs and scene graphs. Right, so in particular, the schedule overall this week will look something like that. This is, of course, subject to change, right? So if we notice that we need some more time here or there and so on, so things will move. And also the times are not exact. So we try to always make the lunch break at 12 and always finish towards like 4:30 latest, 3:30 latest, right? But it might be that we spend a bit more than half an hour on one topic and a bit less than half an hour on the other topic, right? So it will be slightly different. We will have 3 guest speakers this year. So Pascal Friedrich will teach us something about explainable AI in material sciences. Wolfgang Stammer, like a colleague from Pascal is of course from KIT. Wolfgang Stammer, a colleague from Darmstadt, will teach us something about rational AI, in particular concept vectors and concept bottleneck approaches and so on. He has amazing work in that regard, so I'm super excited about that we could convince him to drop by this week, right? And then towards the end on Friday, Rudolf Triebel from KT and DLR. DLR is the Deutsche Luft- und Raumfahrt, so German NASA. I will tell something about XAI and robot vision, right? And then again, towards the end over here, we will have like our own current research. Yeah, we prepared 3 little in-person exercises here, right? That we will again plan to give tomorrow, Wednesday, and on Friday. That will cover always some of the topics on the previous lectures, the previous day lectures. So we have like some part today in the afternoon for some self-study, and tomorrow in the exercise we actually like talk about this in more detail. Okay, cool. So the lecture structure as a whole, as I mentioned, will basically be like the schedule, right? Something that I love to do is what I call 5 and 5. So how many of you have seen lectures with me already? I see at least some familiar faces. That's a lot of familiar faces. So how many of you have seen, like what lectures did you have with me? Like AI2? Any other lectures? What other lecture? Reinforcement learning, I guess?
No, the advanced AI.
So then this is AI2. Okay, no, cool. That's still nice. Yeah, so you already know like my whole spiel about the 30-minute lecture plus 5 and 5 exercises, right? So like I try to break down like after a certain block, like this whole thing into like 5 minutes of you coming up with questions, 5 minutes of exchanging questions, and then ideally 5 minutes afterwards of me like discussing with you what the solutions could be to these questions, right? So the idea is there that so you should already now get out your like whatever your mode of taking notes is, right? Like a blog, a paper, tablet, whatever, right? So that in the next lectures or the next couple of half-hour blocks, you already take some notes. And the idea is that you always come up with like one easy question. So the one that you think like everybody should be able to answer afterwards, right? One middle question where you think like, oh, like everybody that really paid attention should be able to answer it. And a hard question where you'd be like, okay, so this might be some transfer, or this is something that I believe could be correct, but I'm not 100% sure, and so on, right? So these 3 questions. And you don't have to do it by yourself. Find your neighbors, left, right, and discuss with them. So I don't expect every one of you to have like these 3 questions, right? But like as a little group. And then you exchange your 5 questions, or like your 3 questions with a neighboring group. And then you answer their questions, they answer your questions, and so on, right? And the whole idea behind this, for those of you that don't know it, is that basically after 30 minutes at most, right, none of you will pay attention to me anymore, right? So like your brain will be saturated with information, right? Because it's basically a one-way street, me talking, you absorbing. So what we need is kind of like a little bit of a like break of this pattern to stimulate your brain again in order to pay attention again, right? And the way we do this is by, instead of you absorbing information, you have to provide information, right? So you have to query yourself, you have to think about what you just heard, right? And you have to try to formulate it somehow and then think about the questions of somebody else, right? So first problem statement, then problem solution, right? And that basically breaks this pattern of just absorbing information, which allows you to afterwards start again with the observation, with the absorbing. Does it make sense? Okay, so that's basically the brain chemistry behind this, if you want, right? Not really brain chemistry, don't quote me on that one. But anyways, so that's the idea. Yeah, so, and also like it helps you to break down this in chunks. Of course, we won't manage for it to always be 30 minutes. Sometimes it will be a bit more, sometimes it will be a bit less, right? But we're trying to stick something around, somewhere around that time frame, right? Okay, so the exam will be on the 26th of August, so not too long from today, right? And I was supposed to tell you it will be at 8 a.m. Like I didn't pick the time slot. Don't hate me. Paul also didn't pick the time slot. Don't hate him either. By the way, Paul all the way back, hiding, eating, right, having breakfast right now while all of you have to work. Like you can hate him for that, right? No, but Paul will be our assistant this week, right? So if any questions about the exercises or whatever, Paul is the person to speak to. Okay, cool. With this, I think I discussed this all already, right? So this is basically just what I mentioned with the attention span and so on, right? Yeah, so like usually a lot of people think like, oh, like we want to, like you just want like basically us to come up with the exam questions. We have enough exam questions, right? So whatever you ask will not be exam questions necessarily. They might like accidentally be similar to exam questions. We might get inspired by some of them, right? But that's not the reason why we're doing this, okay? But it might be really, really good for you to think about, oh, if I think about these questions, that might be an exam question, because very often you just absorb information and you don't actually realize that you've learned something that is examinable, right? So right away, like after this 5 minutes, that's the idea. However, I'm always very curious about like the questions that you have. So if you don't actually feel comfortable in like telling me your questions afterwards, I would really appreciate if you put them on a piece of paper or you send them to us via email or something like this, because I'm always curious about what you think could be good, easy, middle, or hard questions, right? Just for us basically to assess also how much you understand and how much you actually where you set the difficulties, right, for the exam. And you just have to take our word for it that we don't use that as exam questions. Okay, cool. So with this, we've done with the Orga thing. I hope I didn't forget anything. Paul, did I forget anything? That's a no. Okay, so any questions so far? Cool. Good start. You missed everything. Like, no, that's all good. Like your colleagues will tell you about this. Okay. So let's start then with directly the first intro. Oh, one thing I didn't talk about. Slides. So we can upload them ahead of time, right? So we have like basically for the whole day, we always have the slides ready, right? So we can just provide them to you. We didn't do it so far because I wanted to gauge your opinion if you really need them or not, for the following reason. So like you will say like, of course I want to have the slides in advance, right? Like that's because that's one of the first things that you guys said, but like, or like your colleagues usually say. But the thing is that we have slides, and I will talk a lot about the slides. There will be stuff that is not necessarily ideally directly visible on the slides, right? So I think there's a lot of value in you paying attention to me. And this is not because I'm an egomaniac. I am an egomaniac, but that's a different story, right? No, this is because it actually makes sense, right? For you to pay attention to what I'm saying instead of you looking down the slides and trying to take notes, right? Note taking is important, don't get me wrong, but you can do this on a piece of paper or whatever, right? Like, because if you do it on the slides, you always try to like make it somehow whatever, like very close there. So I feel that if you don't have the PDFs ahead of time, you might be inclined to pay more attention to what's happening up front, right? So what is your self-assessment on that one? Do you agree with this assessment? Yeah? So who disagrees with me? Feel free to, by the way, feel free to disagree with me. So you still want to have the PDFs? Okay. So like let's get so who wants to have the PDF ahead of time anyways? Okay, let's do. So we're gonna send like Paul will upload the PDFs now, right? At least for today. Well, let's do like for now the first block until lunch, and then during lunch we upload the other ones so that you don't have too much at once. But then I still urge all of you that agreed with me to just have them, but only take them when you really need them, and other than that, like, pay attention to me, right? Does it make sense? Okay, cool. So we're still gonna start, and Paul will like give you the slides afterwards, or like we'll upload them and let us know once they're uploaded. Okay. So let's do this one now. So I'm going to start with a little introduction onto the whole topic. So for those of you that seen Advanced AI this year, you might already be familiar with part of the introduction here. I'm not sure. I think Max gave it this year at AI2. So like you're gonna afterwards you can see like if he did it similar to me or not. Okay. So what is artificial intelligence? So that's the first question. So how many of you have seen like or like have visited lectures like on AI in general? Like all of you, okay? Okay, cool. So still like maybe something that you haven't heard is like one of the original definitions, right, by McCarthy. That is that science and engineering of making intelligent machines, right? So that's great. So another more current definition would basically be like explainable artificial intelligence, right? Or like if we talk now why we need to explain it, it's essential to ensure transparency, trust, and accountability in AI systems, enabling humans to understand the decision-making process and potential biases, especially in critical applications like healthcare, finance, and autonomous vehicles. And that is the definition by ChatGPT. So back when I first started this lecture and so on, I basically just asked ChatGPT back then. I don't know which version it was anymore. And that was basically what gave to me, which is fine. And then I was like, okay, so what is the definition of ChatGPT for AI? Which you can see is significantly more complex than what McCarthy defined, right? AI is a branch of computer science that involves training machine learning models on data sets to enable computers to learn from data and make predictions and decisions. I think we can still agree with that definition, which is fine, right? But the interesting aspect here is actually machine learning models and data sets, right? And that's where the XAI comes in. So if we actually have like these machine learning models, we kind of want to be able to somehow interpret them, right? Or explain them ideally. And also we want to maybe use that to basically define or like see if there's anything wrong with our data set. And like the data set bias or the data set issue will be something that we'll talk about in the intro, not too much in the lecture as a whole, but I think it's still worth mentioning at least, right? So if we talk about data sets, we have our data set definition, for instance, like this tabular definition here, right? So let's say we have 5 different columns, like in terms of properties, right? The age, the name, score, limit, and interest. So this could be, for instance, the score for a credit card, right? So in the US, this is like super important. You want to have a high score or good score so that you can actually get better deals or better interest deals, right? So, and then like we call the first aspects, like the name, the age, and the score, the first few properties we would call inputs or features. They're not necessarily the same, but for the sake of simplicity here, we treat them identical, right? Inputs and features, for instance, like the name, again, the age and the score. And then on the other side, we have our targets, right? Our target values, in this case, for instance, limit and interest, which is usually something that we want to predict in the model, right? So if I give you like a new data point, like the 4th one, Rudy, 38, score of, I don't know what it is, right? So what would be the credit card, like the credit limit that I would get if I apply for a new credit card, right? And what would be the interest rate on that one? So that will be basically our new assumption. So or like our new query there for targets. So, and all of the rows obviously are data points, right? So Alice, Bob, and Charlie. So now with this, right, inputs and features, as I mentioned, are not necessarily synonymous, right? What the actual difference would be, so we have an input, which usually we denote as something like X, right? So this could be an image, but this could also be literally just like this, the name, the age, and score, or just one of those properties, right? Or just like an image of like myself, or like some values that describe me, right? And features are actually functions of that input, right? So like, let's say me as a person is a data point, and my features are, for instance, my name, my age, and my score, my credit score, for instance, right? And we have like difference in terms of models. So some models like assume or require explicit features. So those are like hand model features. something that I came or like whoever came up with, right? And whoever uses this model. And other approaches, like for instance, neural networks, are very good in terms of extracting those features by themselves, right? So like neural networks are very good feature extractors, right? So they try to learn the features without having them explicitly given. And of course, there's like also some interpolation between those two, where you have like some manually designed features and some learned features, right? Okay, so machine learning now, which is the second part of the important definition that we had earlier, right, is now the idea that we can train a model, whatever that is, in order to give us the output or prediction. For instance, in our case, like for the limit and the credit, right? And then we kind of like have some loss, some measure, right? That helps us like to or rather that with this loss, by optimizing this loss, we assume that we become better in predicting, right? So something very common is basically just like the reconstruction loss or like an L2 loss, saying that, okay, I have these outputs that I have in my training set, and just using the features of the training set, I want to reproduce the outputs of my training set, right? Basically just this direct loss, mean squared error loss or whatever, right? So that was like a very common loss, for instance, in supervised learning. And with this, we assume that if we actually optimize this loss, then we are able to do good predictions, right? So, and then the learning method is actually the one that now takes this loss and updates the parameters of our model, right, in order to improve the prediction. So now the question is, why do we need interpretability or explainability here? Well, let's look at a little example. So let's assume we have those like data points, right? And our goal is to predict if these leaves in here in this data set are healthy or not, right? If we basically have like some like bad spots in there, if we say like, okay, there's a disease in there. And I mean, all of us, we can see this very clearly, right? So there's like these black spots in there. So obviously all of those are sick leaves, right? So, and then we say like, yes, those are sick leaves. And we train a model on this. And now we basically get like some in the wild example, right? Like that kind of thing. So the problem is that even though here we train very well and we're very accurate, right? And we have like 90% or whatever percentage accuracy, right? We actually make a bad prediction. We actually say like, oh no, this is a healthy leaf, right? So there is no disease recognized. And now the question becomes why? Why is that the case? And we might have immediately our intuition. So what would be some intuition that you all have? Any idea?
Train on a different kind of leaves. So this is an out of distribution example.
That's correct. So basically, the kind of leaves that we've seen, they look different, right? So they were in a different setting. So this is what we usually refer to as an OOD or distribution data point, right? And a lot of supervised learning methods break down in that regard, right? So they're actually like kind of limited to that. And in other lectures, like reinforcement learning and so on, we talk in detail about why this is the case. Okay, but as a counterexample, out of distribution, but the spots are the same, right? So if our model would have learned to just detect spots, right, it should still have performed well. So yeah. So I mean, you're correct, right? This is the issue. But what I'm saying is that if we actually look now, if we actually apply now explainability, then the question is now, why is this an out of distribution data point, or why is it like, why does it break down here? And if we use, for instance, in this case, saliency maps, we can see that what it actually learned is not to focus on the spots, right, on the black spots, but on the discoloration of the liquid that the leaf is in, that is due to the black spots, right? Because this was a stronger feature. So the model actually learned the right thing, like to classify correctly, for the wrong reason, right? So, and this is basically why we need to explainability in there or introspection to see what our actual prediction is based on. Because even though the prediction seems to be correct or accurate or whatever, right, it might be so for the wrong reasons. And that's a problem, right? And that's not only a hypothetical problem, right? So that is a very, very real problem. So for instance, consider the COMPASS system, right? The COMPASS system is the Correctional Offender Management Profiling and or for Alternative Sanctions System, right? So like, obviously they came up with the name after they had the acronym, but like whatever, right? So the thing is, what is that system? Has any one of you heard about this before, other than in the AI2 lecture, right? So the Compass system is a actual system that is used in the US, right, in some states or in some districts. To the best of my knowledge, that is used by judges. So in the US, there's a lot of sentencing for offenders, right? Like for people that don't switch off their phone in lectures, for instance, right? So that come before a judge, and the judge basically then says, like, okay, like I'll sentence you to X, right? So they don't have this fixed, rigid sentencings, but it's somehow like subject to whatever the judge deems, right? So in order to help the judges to say like, okay, I don't know if this person like is really trustworthy, or like if I believe that a person will do good if I have a more lenient sentencing on something like this, right? They develop this compass system. So the judges now can use this compass system and say like, okay, I put in all the information about the subject, right? Or about the, in this case, shouldn't call him subject, but like the person in front of the judge, right? And say like, okay, what are the chances that this person will repeat the offense that it did already, right? So that this person will become a repeat offender. Not that it is a repeat offender, that the person will become a repeat offender, right? So, and with this system, the system then gives you some percentage. The judge can basically use this and say like, okay, so in this case, the system says that I cannot really trust you, that you will become violent again, or you will steal again, or you will like leave your phone on again, right? So these kind of things. So I basically, like you have your title now, you'll be the phone guy now, just so you know, right? So anyways, so that the system, so the judge basically will be like, okay, I will give you a more stringent sentencing, right? So you will be like harsher sentenced, right, for this reason. And that is a very important system to use, right? So we want to be sure that the system is a good system if we use it like that, right? So first of all, like first question, how many of you think this is a good application for machine learning? None, right? It's completely crazy. But anyways, so let's say like the compass system actually has an accuracy of above 60%, right? Like 68, I believe, something like this. So that's actually like quite good. So you might say, okay, in this case, is this a good system? Is this an accurate system? So who thinks that with this information now, it might make sense to apply the system, right? Or at least again, the system doesn't make any decisions. This is just a recommender system for the judge, right? So yeah. For those of you that even think like, okay, this is actually not that bad, right? Like 68%. So like judges can it's okay to use them. If we actually look at false positives, right, and false negatives, there is a huge problem, right? Because like, yeah, so obviously, like if we look at those values, like we would like them to be much lower, right? So than what they are. So that's an issue. So, but that's not the only issue with Compass, right? So the next question actually becomes, does Compass discriminate against black defenders, right? So if we actually now have like people like with different ethnicities in front of the judge, right? How does Compass perform now? And this is like a super serious topic, right? So and we can actually see that while the accuracy is still the same or very close to the same, the actual important aspects like false positive and false negative rates are significantly worse, right? So like this now basically opens up the issue, like is this a discriminatory system, right? And this is why we need explainability. We need to be able to look into the system and see like what it bases its decisions on, right? So this question, is Compass racist or is Compass like a problem, right? Like in terms of discrimination, was basically investigated by Angwin et al. In 2016. And the answer was like, yes, because the false positive and false negative rates are significantly worse than for white defendants, right? So this is a discriminatory system. We shouldn't use that. Okay, so who agrees with that statement? Like I hope most of you, right? Like, okay, good. So now other researchers actually looked at the study again of Angwin et al. And like at Compass and how it predicts. I was like, wait a second, right? So you're actually ignoring correlated factors, right? So like you assume that all of this decision making is based on, let's say, skin color, right? However, you conveniently ignored other features that are accessed by Compass, right? That might be important for this decision too, and that the skin color is just correlated to this other information. For instance, housing, right, employment status, these kind of things. Now you can argue, okay, like housing issues and employment issues might correlate to the skin color beforehand, but Compass doesn't know that, right? So there might be discrimination before all of this that causes this correlation, But that's not the question here. The question is, Compass gets all of this information, makes a decision, right? So is Compass racist or not, right? Or like discriminating? And like Flores et al. Basically said, no, it's not, right? Because like the major features that it focuses on are actually others, right? So they're not the skin color, but the other things that might correlate to skin color, but those are not the ones that Compass actually focuses on. Does it make sense? So now again, the question is Compass racist or not, right? And I think like that's why because people are still unhappy with that decision. There was yet another study, and it said maybe, but it's not more racist than humans, right? So what they actually did is they took the same cases that Compass was working on, right, and basically asked humans, everyday humans, for this and did a study there, and it turns out that it was very much on par with what Compass would recommend, right? Which speaks more about the society than about Compass here. Sure, go on in. No need to knock on worries. Join us. Yeah, so basically you can see that the problem there lies like maybe in the society and like on all of these other correlations. So yeah, so it's not only the system itself, not only Compass itself. Okay. So any questions about this so far?
Just going to decide differently than regular humans.
A good question. I'm actually not aware of that. So the question for the recording is if there were studies where they looked particularly at judges, and so if judges would decide differently than the participants in the human sample group here. And I'm not aware of that, but like that's worth maybe looking into. Thank you. Okay. So the thing is, if we actually look at this, one thing that is important to understand now at this point, right, is that none of these measures, right, the accuracy, the false positive rate, the false negative rate, none of this tells us actually if Compass is discriminating or not. Why not? Because even though it looks horrible, right? Like I agree that this is bad, right? This should not be the case. There's no question about it. But this doesn't tell us if Compass is discriminating or not, because what we have here are actually performance measures, right? And performance measures only tell us how the model performs, right? It doesn't tell us anything why it performs the way it does, right? So, and this is what explainability or XAI actually tries to tackle. So the question of why is that this prediction happening as it is, not how it predicts, right? Does it make sense that there's like a significant difference between the performance measure and the explainability? Okay, good. So we're gonna look at two different types of models. Like today will be, today will be more on a simple model, right? So if we actually have our like good sample and our bad sample, right, and we want today, and like some simple models could like things like decision trees, right? So for instance, like this would be something where we can break down our decision in kind of tree structure or like in any other interpretable way. So something where the model itself has interpretability, right? And we can say like, okay, so we came to the conclusion that the bottom one is like a bad guy by seeing that like it wears a mask, right? And the good guy is basically because it doesn't wear a mask and has like cute ears, right? So that makes cute individuals, right? So in complex models, on the other hand, there we try to be more, so like we don't design these features or we don't determine this, like you don't have the interpretable structure, so we cannot interpret the model itself anymore. So we're trying to interpret what the decision is based on in a different way, for instance, through post-hoc interpretability, right? So we look at the decision made and then try to analyze what the features were basically like the foundation for this decision, right? So here again, basically looking at the images and then highlighting what led to positive or to a negative classification, right? And those are complex models. And then we can also analyze what happens if we have these fringe cases, right? So show of hands, who thinks like the upper one is evil? Looks more evil, like who looks more evil, upper one or lower one? Like I just like who thinks upper one looks more evil, right? So it is the ears. The ears make it cute. The ears make it like nice, I think. Anyways, so that's our part for the interpretability or like for the introduction. So Paul, do we do a 5 and 5 now already? No? Do you guys want to have your first 5 and 5? I see a lot of no's. I don't see any yeses, so let's go with yes. Right. So like our first 5 and 5 break. Let's go. We can make it a short one. We can make it a 3 and 3, right? So just so that you get warm, right? We don't expect anything complicated, but just something that you get warmed up. Okay.